Now coming to the next question. A review of electricity bills of a process plant was conducted as a part of energy audit. The plant has a contract demand of 3000 kVA with the power supply company. The average maximum demand of the plant is 2000 kVA per month at the power factor of 0.95. The maximum demand is billed at the rate of Rs 350 per kVA per month. The minimum billable maximum demand is 80% of the contract demand. An incentive of 0.5% reduction in energy charges component of electricity bill are provided for every 0.01 increase in the power factor over and above 0.95. The average energy charge component for electricity bill per month for this plant is Rs 80 lakhs. So here we have to calculate the following. If this plant decides to improve the power factor to unity, determine its annual monetary benefits. Second is, what will be the simple payback period if the cost per unit capacitor bank installed is Rs 12,000 per kVAr. Now coming to the solution part. First we'll find out the drawn, that is active power, which is nothing but the demand multiplied by power factor. So it is 2000 kVA into 0.95, which is nothing but 1900 kilowatt. Next is to find out the kVAr required to improve the power factor from 0.95 to 1, which we have read earlier also, which is equal to active power multiplied by the tan theta 1 minus tan theta 2, which is tan of cos inverse 0.95 minus tan of cos inverse of 1. After calculating this, we get the value of 1900 multiplied by 0.329 minus 0, which is nothing but 625.1 kVAr. So the capacitor required is 625.1 kVAr. Next, we find out the cost of this power factor capacitor, since the rate per kVAr is given Rs 1200 per kVAr. So for 625 kVAr, the cost would be Rs 1200 multiplied by 625, that is Rs 7,50,120 rupees. Now let's calculate the maximum demand at the unity power factor, that is kilowatt divided by 1, that is equal to 1900 kVA. This is the minimum billable amount. So 80% of the contract demand, that is 3000 kVA, is 0.8 multiplied by 3000, which is equal to 2400 kVA. We know that the demand of the plant earlier was 2000 kVA per month. So as per the minimum billable amount, the plant had to pay as per the 2400 kVA. Now also, though the demand has decreased to 1900 kVA, but as per the minimum billing requirement, plant has to pay as per the 2400 kVA. So the reduction in maximum demand charges would be nil. Now let's find out the percentage reduction in energy charges due to the improvement in the power factor. We know that there is a reduction of 0.5% for every 0.01 increase in the power factor. So here the percentage reduction is nothing but 1 minus 0.95 divided by 0.01, this whole multiplied by 0.5%, which is equal to 2.5%. It's given in the question that the monthly energy cost component of the bill is rupees 80 lakhs. So the reduction in the energy cost component is nothing but rupees 80 lakhs multiplied by 2.5 percentage, which is equal to rupees 2 lakhs per month. Now the annual reduction in the energy cost owing to the power factor improvement is rupees 2 lakhs multiplied by 12, that is rupees 24 lakhs. Now let's find out the annual saving in the electricity bill is equal to 0 plus rupees 24 lakhs, which is equal to rupees 24 lakhs. Our investment is the cost of the capacitor, that is rupees 7 lakhs 50,000. So to find out the payback period, we have to divide the investment by the annual saving multiplied by 12 to find out the number of months, which is equal to 7 lakhs 50,000 divided by 24 lakhs multiplied by 12 months, that is equal to 3.75 months. So the payback period is 3.75 months.